Imagine an ordinary night on Earth. Cities hum, oceans breathe in slow tides, and the planet rotates with its familiar, steady rhythm. Telescopes scan the skies as they always do, tracking the paths of comets, debris, and asteroids drifting through the solar system. Most pose no threat. Most glide silently past. But then astronomers detect something strange: an asteroid on a collision course with Earth. Not unusual in itself, until they measure its properties. The object has no absorption features, no fragmentation patterns, no irregular surfaces. It behaves like a flawless sphere, smooth, dense, perfect. It reflects nearly all energy that touches it, and then comes the impossible conclusion: this asteroid is perfectly elastic. In our universe, nothing is perfectly elastic. No real material bounces back without losing some energy to heat, sound, or deformation. But this thing does. It shouldn't exist, yet there it is. An unblemished diamond of physics gone rogue, tumbling silently through space with a trajectory that leads straight toward Earth. Governments panic. Agencies calculate scenarios. Normally, an asteroid impact would be catastrophic because of energy transfer, shockwaves, heat, vaporization. But a perfectly elastic asteroid doesn't absorb energy. It reflects it. Instead of burying into Earth or exploding on contact, it will bounce. It will rebound with almost the same speed it arrived, which means terrifyingly Earth will rebound too. As it enters the atmosphere, something extraordinary happens. No fireball, no plasma sheath. The air molecules hit the asteroid and bounce off with perfect efficiency, transferring no energy. Instead of heating up, the surrounding air grows wildly turbulent. Winds whip into spirals as the atmosphere recoils from the object's passage like a trampoline being punched. Weather systems warp instantly. Jet streams kink. Clouds twist into unnatural vortices. Millions watch the sky as the asteroid descends, a silvery, eerie sphere that neither burns nor roars. It passes through the atmosphere like a stone dropping through water, displacing everything but losing no speed. When it hits the ground, somewhere in the middle of an uninhabited desert, the world holds its breath. The impact is silent for a fraction of a second. Then physics erupts. Instead of exploding into the Earth, the asteroid hits the planet like a cue ball hitting a giant rubber ball. The ground beneath it collapses inward, compressed by the force of the collision. A crater forms, but only for an instant, because the asteroid launches back upward with nearly the same speed it arrived. The ground rebounds as well, rippling outward in massive seismic waves that race across continents. The shockwave is unlike anything Earth has ever known. It doesn't come from heat or impact destruction, it comes from momentum. The planet shudders like a gong struck by a celestial hammer. Cities thousands of kilometers away shake violently. Buildings sway, windows explode, ocean basins tremble, sending out tsunamis that travel at breathtaking speeds. The entire crust vibrates. But that is only the beginning. As the asteroid bounces upward back into space, Earth receives an equal and opposite reaction. The planet shifts slightly in its orbit. Not by much, but enough to matter. Enough that astronomers immediately notice the wobble. Earth's rotational speed changes minutely. Days shorten by a fraction of a second. Seasons drift. Weather patterns realign. Meanwhile, the asteroid rises thousands of kilometers, slows under Earth's gravity, and then begins to fall again. Because of its elasticity, it cannot stop. It cannot be captured. It must continue bouncing until something interrupts its cycle. It falls again, this time striking a different region of the planet as Earth's rotation brings new land under its path. Another massive rebound, another planetary vibration, another orbital nudge. Each impact breaks more infrastructure. Fault lines rupture, dormant volcanoes awaken from the jolt. Mountain ranges groan as tectonic plates grind. The oceans slosh violently, creating waves that batter coastlines. After the third bounce, the asteroid is now high enough that it grazes the edge of the atmosphere, still losing no energy. But Earth? Earth is accumulating chaos. Scientists calculate the grim truth. The asteroid may continue bouncing for hours, days, maybe longer. Every collision moves Earth slightly farther from its original orbit. Eventually, if unchecked, the planet could drift enough to freeze or fry. Humanity witnesses each rebound with a mixture of awe and dread, hoping for some natural dissipative force that doesn't exist. But finally, on the asteroid's 7th or 8th descent, a miracle of cosmic coincidence occurs. It strikes the Pacific Ocean. Water, unlike rock or air, cannot return energy perfectly. When the asteroid hits the ocean, the water behaves like a deformable cushion, absorbing a small portion of the momentum. Not much, but enough. The asteroid rebounds weaker this time. It ascends only halfway to its prior height. On its next descent, it hits the ocean again. Less bounce, less recoil. The cycles shorten. Eventually, the asteroid's path becomes a stuttering series of weaker impacts that churn the Pacific into colossal whirlpools and waves towering like skyscrapers. Finally, on the last impact, the asteroid loses enough energy to sink beneath the waves, plunging into the deep ocean where water pressure and drag slow it at last. It settles on the seafloor, still perfectly elastic, still unbreakable, but finally motionless. Earth, however, is forever changed. Its orbit is shifted slightly, but enough that climate zones migrate. The axial wobble intensifies, altering seasons. Length of day stabilizes at a new value. Coastlines rewrite themselves from the tsunamis. Volcanoes triggered by the seismic chaos continue erupting for years. Entire ecosystems must adapt to the new rhythms of temperature and light. Generations later, scientists point to that event as the day Earth learned the true fragility of its cosmic ballet. An encounter not with destruction, but with physics in its purest, most merciless form. And miles beneath the Pacific, resting silently in the abyss, lies the perfect asteroid, waiting, elastic, eternal.